This is the PWM module. It gives you select fire solenoid control and PWM motor control. This is good if you have a solenoid build and you want, say, full auto and semi-auto. That's when it switches between two. This guy can't do burst fire. Or let's say you have some sort of flywheel setup. You can get like a really, really high FPS one with like Eclipse setup or Daybreaks that can hit up to 170. But let's say you play HVZ and you don't want to like hurt anybody with 170 FPS. You can easily turn the knob down to dial it down the FPS. So if you want to play with kids or you want to play HVZ, you can do all that within the same setup with the same motors, wheels, and cage. It's super easy too. This guy right here, it actually can't drive the motors by itself, so you need a power driver. That's something that can handle the high power that's required to drive a solenoid or a set of flywheel motors. So you can either choose between the MOSFET Board 2 or the MOSFET Board Plus. This is all within the MOSFET Board ecosystem. So remember these pins I was talking about earlier? If you've checked out the MOSFET Board videos, you actually just stack the PWM module right on top. Since this is all in the same MOSFET Board ecosystem, they're all compatible with each other. So if you want to drive, let's say, just a solenoid or just a single stage flywheel setup, I would recommend the MOSFET Board 2. But if you want to drive more than one solenoid, or you want to drive a multi-stage setup, I would recommend the MOSFET Board Plus. This guy can handle a lot more power, as it has a bigger MOSFET, and it also has 6 holes right here, so you can solder on more XC60s. I found it a huge pain in stuff like the Worker Dominator to solder like 3 sets of cages onto 2 wires on the standard MOSFET board. This is why I think if you're going multi-stage, having 3 holes is critical. And it's just a huge convenience factor. So let's see what you need to get it set up and running. The kit itself includes all the parts you'll need. This includes the 2-pin JST connector. This is going to be your trigger. And you want to use a switch. The switch isn't included, and you want to hook up the 2-pin JST connector to the switch. You want to solder to the common tab and the normally open tab of your switch. Or if you're using a stock switch, which you of course can since this uses a MOSFET, you want to solder to the middle pin, and the pin furthest back. Sometimes I've seen the stock switches come with only 2 pins. You can just solder onto both of those if the switch you're choosing has that. And again, you can use both these stock Nerf switches, or you can go bigger if you want, like with a 21 amp Omron switch or a Cherry switch. Although those are completely overkill. I just use these micro switches, the stock ones, in all my builds. You also get a knob. This is a potentiometer, and its corresponding 3-pin cable. So when soldering this cable, you want to make sure that the middle wire goes to the middle pin of the potentiometer, or the knob. And other than that, you can just solder any of the 2 outside wires. Either way, it doesn't matter. And it comes with a knob, which you can just pull off really easily. And it turns. So this is what you're going to use to calibrate the solenoid when the board is in solenoid operation. Or you can just dial up and down the rate of fire or FPS. As you can see here, it comes with a little washer and a nut that can screw around the base. This makes it really easy to mount in your blaster and keep it there. So you won't need any glue or anything. You just have to drill a hole and attach these to your blaster. And the knob style is a bit different depending on what I have in stock. But in the future, I'll have a selection so you can choose what kind of knob you want. You can also solder the knob like this, where you solder directly onto the tabs. In this guy, I actually cut them off, but it just depends on what your situation needs. If you have the space, I'd recommend doing it this way. But if you're more tight on space, this way is perfectly fine. I would recommend this way since it's actually a bit stronger, since the wires here solder directly to the board. So if you move the wire too much, they can actually pull off. And remember to use heat shrink and everything. And last but not least, you have the 2-position switch. Included is this little rocker switch right here, or slider switch. But you can also choose to have a rocker switch or one of these bigger switches here. I like to use this guy, that's just personal preference, but it's all up to you. If you decide to go for this variant of the switch, it also includes the necessary screws and stuff to mount onto the blaster. This just makes it a lot easier. And when wiring this up, you'll get, of course, another included 3-pin JST connector, and to solder the middle wire onto the middle pin of the switch, and then solder the other two whichever way you want. It can go either way. Just the most important part is having the middle wire to the middle pin. This is applicable for both styles of switches. So that's all you'll need. Just takes a tiny bit of soldering directly onto the switches and the knobs. So just to recap, you'll need a knob, a trigger switch, and a 2-position switch. 2 jumper caps are also included. One of them is for selecting which kind of mode you want to do. So if you look here on the board itself, you see solenoid, fast, medium, slow. And these correspond to the rate of fire you want for the solenoid to fire at. And the last one down here is for the flywheels. So just put the jumper cap or whichever setting you want. I'll show slow first on solenoid control. So slow is the second one from the bottom. So I'll put that, flip it over, put it in the back, and plug in the knob. It's going to say knob right there. Plug in the knob over here. It's actually polarized, so you can't like connect it backwards. Same thing with the 2-position switch. That's not the trigger. I'm going to plug that in right here where it says PWM select. That's a terrible name. I'll be changing that in the next variant. And last but not least, the trigger. And just put that where it says trigger. That's it. And then stack the 3 pins on top. Make sure that you're getting all 3 pins. So you don't want to be like 2 pins in, 1 pin exposed. That's bad. You just want to do it like this. Make sure you have all the wiring correct or else it won't operate properly. And that's it. I'll be demonstrating this with the MOSFET Board 2 first, and then we can go in the MOSFET Board Plus after it. So because it's in solenoid mode, let's grab a solenoid. Let's grab a LiPo. This is a 3S. The MOSFET board itself can handle up to 5S, I believe, but the PWM module can only handle up to 3S. So don't go 4S when using these setups. Plug that in. And that's it. Look how easy that was. That's a slow setting for full auto. Now I can just turn this guy. And I got semi-auto. The knob for this is, when it's in solenoid operation, is to turn, when you turn it, it would calibrate the solenoid when firing in full auto mode. So let's switch it back to full auto and I'll show you. So notice how you can change the rate of fire a little bit, but it's mainly for calibration since different solenoids and different sizes have different cycle times. So maybe some of them have bigger springs, some of them have smaller springs, some of them are more powerful. You can calibrate that all with the knob. And there are 3 speed settings. The first one I showed you was slow. That's about 4 to 6 darts per second. Let's try medium. So simply just move the jumper cap over. Plug in the board. And I also want to reiterate that you cannot do motor control or solenoid control and motor control simultaneously. If you want to do motor control and solenoid control in the same build, you'll need 1 PWM module and 1 MOSFET board per solenoid or per motors. You can do multiple motors within the same PWM module using the MOSFET board plus, but you can't do solenoid and motor with the same MOSFET board. If you want to learn more about that, you can look in the description of my website. I have a huge FAQ section, so any questions you might have on like what kind of components you want to buy and stuff, that's all going to be there. So just go medium. That's a lot faster. And notice how the solenoid wasn't fully going forward and fully going back. That's when I would use the knob for a little bit. Change the knob. Now it's That's too much, so then I can just change the knob to get it perfectly as I want. And last but not least, let's check out the fast one. Depending on the strength of your solenoid and your spring strength, the fast mode might be too fast for your solenoid. But it's also good for if you want to do half-length builds where the solenoids are a lot smaller, the stroke length is shorter. The fast would be perfect for that. Well, it's going to be fast, of course, but it'll work perfectly fine. Use the knob again to calibrate it. You'll need to calibrate it a little bit every single time you want to switch fire rates. It's a bit weak. Yeah. So it's super fast. It's not fast enough for this solenoid, but it's good for smaller solenoids. Like this one. This guy's a lot smaller. Probably too small for half lengths, but it's cool nonetheless. Let's plug that in. Perfect. And of course, select fire so I can switch this back. And I'll get semi-auto fire. Okay, now let's try it with flywheel motors. This works for flywheel motors or for pusher motors. So if you want to do it with the flywheel setup, you can do, the knob will change the FPS because that's how fast the motors spin. But if you're doing a pusher, like a rapid strike pusher or a hyperfire pusher, this will give you variable darts per second. So let's change it down to this guy, which is, of course, the flywheels option. That's kind of misleading since this works for pusher motors and for flywheel motors. So I'm going to rename the text in a future variant. Make sure it's plugged in correctly. Unplug the solenoid. Plug in the flywheel setup, and let's see it. So with the knob, you can clearly hear the motor spinning faster and slower, but you may notice that when the power is too low, it actually hinders both the torque and the RPM, which means that the motors might not have enough torque, depending on your wheel setup, to spin all the way up to full speed when the power is too low. Let's see, so right now I'm on minimum power, and it's going to give you a beeping sound if it's too little power. That means that you'll have to turn up the power a bit. So let's turn it up there. That's going to depend on the kind of motors you have and also the kind of wheels. Of course, metal wheels are going to be heavier, so you'll need a bit more power to bring them up to full speed. Now, the select fire switch on the solenoid, this switch gives you select fire, right? But on the motors, it's a bit different. So on regular operation, when I'm in the knob mode, I can change the FPS with the knob, but if I don't want that, I can switch it forward and have it go full power. And when it's in full power, the knob has no effect, but just flick it back. And it's back to normal. If you don't want that feature, I've included another jumper cap. So you get 2 jumper caps total. One for fire rate selection or mode selection, and the other to bypass the select fire switch. So if you look closely, you put the jumper cap on the 2 pins forward on this connector. Snap it in, and this will give you only PWM mode and no, the switch won't do anything because it's gone. Let's plug it back in. Let's see that in action. So it's only in PWM mode, if that's what you want. The option is always there. If you don't want that, you can just simply not use that jumper cap. And let's see it for using a pusher motor. So this would be useful if you want to conserve ammo in a long event, you can use like a Wolverine that can give you 20 darts per second, but if you want to turn it down to maybe a more usable 5 to 10 darts per second, that's totally an option. One thing I want to note is that as of the making of this video, I don't have a solution for motor braking, which means that you won't get entirely consistent cycle control. So notice how when I let go of the trigger, the pusher spins, it moves a little bit more after the trigger is released. This could be more of an issue on the hyperfire pusher, which uses a belt, but it's not as bad on the rapid strike pusher. But if you want to wait for the pusher or for the braking board, that's going to give you a bit more control over what's happening. This issue is a bit more apparent on higher speeds because the motor has more inertia, so it's going to keep spinning. Notice how it fired like 2 extra shots after I left the trigger. If you decide to opt out for the motor braking board, this guy, the Pwm Module, will be same compatibility. Just snap it right on, and you're good to go. I actually bypassed the switch again, but this time it might be a bit more useful if you want to like do a quick dart hose switch. You can use the this switch to do that. It's a bit difficult to remove the jumper cap from the connector with your fingers, so I'd recommend something like an X-Acto knife or just something quick so you can get some leverage to remove it. So you can see right now it's set to the lowest velocity. Now, that's pretty cool. And just a few more notes before I end the video. You will need a power driver that's either the MOSFET Board 2, which is my recommended go-to. It's cheaper, smaller, and can handle basically any motor you can throw at it. It just can't handle multi-stage and stuff. But you can also use the multi-stage one if necessary. You also can't do PWM motor control and solenoid control simultaneously. So again, if you want to do motor control, you need a separate board for that. And if you want to do solenoid, you have to do a separate board for that. I just want to make this really apparent in case, before anyone wants to buy it, to make sure that they're making a good decision. And I can show off the MOSFET Board Plus real quick. It's basically the same, except it has more holes, so you can connect up to 3 sets of flywheel motors or 3 solenoids for whatever reason. But here it only comes with 1, but you can also choose to do more. If you decide to solder your own, this applies to the MOSFET Board 2 or for the MOSFET Board Plus. Make sure that you have the connections proper, so make sure that the battery goes to the battery, the motor goes to the motors, and also make sure that you allow the board to cool before soldering. So when you would solder one wire, wait for it to cool, solder the next wire onto the board, wait for it to cool. This is because too much heat can damage the board and damage the MOSFET and other components on the board. So to prevent that, just wait a few minutes before soldering it to make sure that the board cools entirely. And exactly the same setup, super easy. That's the MOSFET Board Plus. Again, this is just the same. There's also an option for a 3-position switch. So if you want to say change the rate of fire of your solenoid build on the fly, instead of changing the jumpers around and opening your blaster, which is a pain, you can use a 3-position switch. You can add a cap on if you want. This is the same one as the potentiometer or the knob. It's got like some 3 positions. So you can do like fast, medium, slow, and flick between those two right on the fly. You can also print your own, like if you have a printer, you can model and design your own like select fire knob and use that, which would be pretty cool. I'll go over how to use this one in the next video. This was more like a basics kind of video. I just didn't want it to be too long, So the next video is going to be how it works and more complex wiring with it, which means that wiring with this guy and wiring with the other variants of the switch. That's about it. Links to everything will be in the description below. That includes the MOSFET board, the MOSFET board plus, the Pwm module itself, and I also wrote a guide on MOSFETs if you want to get into that, which is all pretty cool since this entire setup, of course, uses MOSFET technology. That's why I can get away with using these really janky wires. They're not that janky. They're actually perfect for this application. But you can use stuff like Nerf stock wiring for a lot of the wiring. Just make sure that all the power stuff is thick wiring. And I plan to open source this soon when I get time. I'll have a link to that in the description as well. It's going to have all like the board files and the schematics and everything. So that's about it. Thanks for watching.